everyone, my name is Quimby and I am a neuroscience PhD student at UC Davis. Today I'll be talking to you about my project titled Sex-Specific Cerebrovascular Reactivity Differences in Autism. So to start out, the developing brain requires twice as much energy as an adult brain. And although the cerebrovasculature is responsible for supplying the brain these energy resources, the cerebrovascular function and the development of it has been understudied in pediatric populations, especially neurodevelopmental conditions such as autism. Autism is a neurodevelopmental condition that's characterized by impaired social communication interaction, as well as restricted and repetitive behaviors. And although autism is diagnosed based on these two factors, there's a variety of behavioral comorbidities, genetics, and other biological factors that contribute to a heterogeneity in autism. One way we can measure cerebrovascular function is through cerebrovascular reactivity, or the capacity for blood vessels to dilate in response to a vasoactive stimuli. An example of a vasoactive stimuli is carbon dioxide, and when we have elevated carbon dioxide in our bloodstream, this causes our cerebral blood vessels to dilate or increase their diameter. We can calculate CBR as the amount of vasodilation per vasoactive stimuli, in this case carbon dioxide. We can measure this blood oxygenation and vasodilation through the blood oxygen level dependent signal of functional magnetic resonance imaging, which measures the amount of oxyhemoglobin to deoxyhemoglobin in the bloodstream. And so when we have an increase in carbon dioxide, we have a vasodilation event and an increase in the bold signal. Previous studies have used fMRI bold signal with gas challenges to measure CBR in adults. However, this requires elevated CO2 inhalation as well as respiratory monitoring, which makes it inaccessible to pediatric populations. So in my project, I'm using a new method of resting state cerebrovascular reactivity mapping, which extracts CO2 fluctuations from the global bold signal itself using a frequency filter. With this method, we can calculate CBR per participant in a resting state fMRI sequence in children. In this case, I use the Autism Brain Imaging Data Exchange, which is a repository of MRI scans of autistic and non-autistic children ages 9 to 12 years old, and identified sex by diagnosis effects in 4 regions of the gray matter, where we see elevated cerebrovascular activity in autistic females compared to non-autistic females, but we don't see that same difference in males. So to conclude, CBR may be a key biomarker of cerebrovascular differences in a subset of autistic children, specifically autistic girls. Thank you.